Hello and welcome back to Oxford Mathematical Admission Test as per October 30, 2019. So here we consider type F, and Daniel Dallas is right here to explain you and give you the most, the clearest explanation and more detailed. All right, so the full test you can find in description below. You can download. I just provide an official link to that. Okay, so here we're just discussing explanations. So we have sine cube x and cosine squared x equals 0. So while x is within 0 and 360 degrees. Okay, it looks like, so when I first just saw it, when I try to explain, so it's a real type A task, maybe a bit harder, but the main strategy I just basically borrow from there, from type A explanation. For those guys who didn't watch type A question, my video about that, just go back and only then return. For those who understand in a short way, I'm going to explain you the shortcut how to do that. So okay, let's start. So first of all, we have sine cube x cos squared, so I just use trigonometric formula to come first to one single function, and will be just minus sine squared x plus 1. That's from trigonometric identity. And now if I input new variable, let's say t, that's good one. So new variable t equal to sine, say squared x, yeah, in this case sine squared x. So what we'll have t, oh no, it's better to input sine x. So, and right now we have t, let's see, t cube, right? We have t cube minus t squared and plus 1. All right, as in the type A question, I would separate t cubed minus t squared equals to -1. So I would like to, to put function y1 from t and the second function y2 from t, which is actually constant, doesn't depend on t. So I input just y2. All right, so the first polynomial is a cubic one, so y1 from t is simply t squared and t minus 1. So actually, however, it's a cubic one with leading coefficient more than 0, so we can set it up here and plot it. So y from t now, and so actually if we factorize, we'll have 0 and 1 as zeros of this polynomial, right? So we can find zeros of the function, equate into 0 and figure out t is 0 and t is 1. So simply we'll have 0 and 1 here, and we just put polynomial of power 3. So it looks like it goes like this. And due to leading coefficient, it goes upward, so it's rising. Okay, mostly rising, I mean. Okay, and here we have another line, y equals to -1. So this is y1 function from t, and here is another one, so at the level of -1, so this is y2. And in this case, it's much easier, right? In the type A, we supposed to estimate, the maximum local turning points in order to judge about like 3,000. So here we don't need to do that because it's clearly seen that there is one point of intersection. So what we can do, we just try to establish the value that delivers us -1. Okay, actually, you ask about how many solutions. Okay, in terms of t, we'll definitely have one. Okay, so we'll definitely have one. So it occurs when t is equal to some number. Okay, so what we can do, we can try to estimate. So probably we can try to estimate and try to see exactly how it goes. For example, You know, I'll even can use some graphing tools and online, so probably to check my assumption, I just put it input the structure like x cubed plus, sorry, minus x squared, and that plus 1 equals, not equals, just plus 1, and just I'm caring about how many solutions. So we'll get the point around, you know, around negative 0.75. So this actually precise value, pretty precise. So t, which deliver the value for t cubed minus t squared equals negative 1, is actually t is negative 0.755. But this is precise, right? And what did you do on exam? Because right now you need somehow to estimate, right? So you actually point t value for that point, for the point of intersection with the graph y1 with y2, is actually one single value for t. So how to arrive to this value and how to understand is it proper and improper? Of course, because we have sine x equals t, so you know that sine x is restricted between -1 and 1. So this value is pretty eligible because in this case sine x equals to negative 0.755. And this is the right time to have a look at the unit circle. So we've got this solution. In case of like many points of intersection, so be careful about these conditions. Don't forget about that. That's intentionally tested here. So, okay, let's drop the unit circle in order to see. So whereas sine is always in vertical so in the vertical axis, so this sine, this cosine x, and we have the value. So actually it's not centered properly. Okay, let's do more precisely. So okay, this -1, so that's why negative 0.75 somewhere here. And we understand that it might be using two angles, right? So this is, I put a red to mark the angles, because have a look back. So our x values is from 0 to 360. Actually, we intentionally given this range for x, so that's the first angle. It's 180 something, right? It's a bit more than 180. And this is actually first value for x. And the second value I put was green one. And the second angle is here. That's okay because it's still within 360 degrees. So that's why it's the second solution. So x1 and 2, so we have two solutions. So be careful about those limits. They're very significant always. So, okay, don't forget about that. So we have two solutions. And that's why, in case the right choice, it's C, I guess, yeah? So two solutions here, all right? So that was a shortcut. Don't forget to subscribe to be in touch with the latest updates. Okay, that was Daniel Dallas with you guys, and see you later.